if f is continuous and alpha is a monotonic on closed interval a, we show that f belongs to R alpha on closed interval AB. Now proof let epsilon is greater than 0 be given. Let us choose neta is greater than 0 such that closed interval alpha b minus alpha a into neta is less than epsilon. For f is continuous on closed and bounded in the interval closed interval AB, it follows that f is uniformly continuous on closed interval AB. Hence, there exists a delta is greater than 0 such that f of x minus f of y is less than neta for all values of x and y belongs to closed interval AB, where modulus x minus y is less than delta. Let P is a partition where x0 is equal to a, x1, x2, so on, xn is equal to b, bracket close, be any partition of closed interval AB such that norms of P is less than delta. Since f is a continuous on closed interval AB, it is also continuous on each subinterval square bracket xi minus 1 and xi square bracket close, and consequently it attains bounds. Let m small mi and capital Mi be the bounds of f on close interval xi minus 1 and xi. Then there exists c and d belongs to close interval xi minus 1 xi such that mi is equal to fc and mi is equal to fd. It follows from that f of d minus f of c is less than neta, so mi minus capital Mi minus small mi is less than neta for I varying from 1 to n, and therefore upper bound of partition pf alpha minus lower bound pf alpha is equal to sigma I varying from 1 to n mi capital Mi minus mi delta alpha I neta sigma I varying from 1 to n delta alpha I which is equal to neta sigma varying from I1 to n square bracket alpha xi minus alpha xi minus 1 is equal to neta alpha x1 minus alpha x0 plus alpha x2 minus alpha x1 plus 1 alpha xn minus alpha xn minus 1 square bracket close, which is equal to neta square alpha xn minus alpha x0. So neta alpha b minus alpha a is less than epsilon from 1. Hence by the theorem f belongs to R alpha if and only if for all values of epsilon greater than 0 there exists a partition P such that upper bound of pf alpha and minus lower bound of pf alpha is less than epsilon. We have f belongs to R alpha.